Hello, everyone. Welcome to the webinar. We will start in just a few moments from now. Thank you. Hello, everyone, and welcome to today's webinar on what's new in SolidCAM 2021 in the new tool table. And this is the second part of this webinar, actually. The first part was given last week by Vinetsky, who is the product manager for SolidCAM, and worked very hard with the team to get actually the new tool table into the program, and it is actually a very, very powerful tool. So without me talking too much, this is Sydney, obviously, and without me talking too much, I'm going to make Michal the presenter. You can ask questions in the question pane, and I'll try to get through them during the webinar as we can. And if I don't get to them, all the questions are still written down, and we can get back to you by email with those questions. So, Michael, you are now the presenter. You can unmute yourself and share your screen, and go ahead.
Was muted. Thank you, Sydney, for the introduction. Hope you hear me well. Okay, can you hear me?
Yes, I hear you very, very well. Go ahead.
Perfect. So today we are continuing with the presentation of SolidCAM 2021. We are more concentrated on a new tool table in this presentation, but I want to show at this stage the power of the tool table, of the toolkit, we call it toolkit now, in the mill tile machines. I will show the process how today's user can use the new tool table, a toolkit, and get the maximum productivity from it. So, as always, we are starting from the tool table. So I want to import holders what I downloaded from third party. I'm using for my needs website sources or machining cloud sources. Any source when you can download the 3D model, it's fine for you. So I downloaded a lot of holders in a state format, okay, for this machine, what I'm going to use. I'm going to present it on Haas military machine, what's using BMT stations for holders. So you see now the number of STL files what I want to import to my tool table, and I'm going to create a tool table. I'm going to toolkit, new tool library, tool components, and this tool table will be used for part creation. So I want to take all these holders to the tool table. So the fastest way to do it is just right click on it, import structure, and I go to the folder and wait a while, and I get, after the conversion, all tool holders imported to my table. So I do it in only one click. What I need to do now is to edit the holders. So I can open the tool view, tool picture view, and go to each holder and define where is my mounting point for the station on the tool on the turret, and also the connection. We call it joints. Okay.
Michal, let me interrupt you just for a moment. You're being asked by a lot of people to show only SolidCAM. They see the audio mixer that you have on the screen, and it makes SolidWorks very small.
It means I'm showing my different stream. Okay, just a second. how I can switch screens here. One second. Oh, okay. Now it's better, Sydney?
Better, much better. Okay, go ahead.
Okay. Okay, sorry for the technical problem. So what we see here is the holder what I imported from STL model, and I just want to define, I'm just dragging, where is my tool mounted. Okay, so I'm going to define here. I can go to other holder and to do same. Okay, just move the point to the highest point on the component. I can do it with all my holders, and especially for this holder, I'm going to define the joint. Okay, you can take the data of the position of the tool mounting directly from the CAD, or you can just measure it on the tool. Okay. Only one thing I'm going to do here, just to rotate my coordinate system. I do it also by rolling the mouse, because I want my z-axis of the joint should be in the same direction as the tool will be mounted on it. Okay. And of course, this holder have a gear inside, so I have to define it like a gear. I can put a limit here. It will be used for operation definition. So it's a way how we define the holders in SolidCAM in tool library. I will not go through the all holders. I will just open ready library what I did before. Okay, so I'm going to edit the tool components library. Okay, I'm calling this label redline as mill tools. Okay, this is a tool manufacturer, and here you can find all tools with predefined mounting points. Okay, I think this library also is included in our install. If not, it will be uploaded to our website, so everybody who uses these tools can use it without the definition. Okay, so that's the way how we're defining the tools for the tool library, the holders. I also can add cutters and chunks, but for this part, I don't want to do it. Okay, so the next stage, it will be to define how we working on the tool assemblies. So I'm going to edit tool assembly, okay? And I'm going to use have a lot of tool assemblies here, okay? And what is, sorry, not tool assembly, I will skip the tool assembly, this is a simple part. Let's go direct to the machine setup, okay? And in machine setup, I already have some assemblies, what I did for particular machine with tools, okay? And it's saved for the next use. I have a lot of different tools combinations, and I can mount it directly on the station to see how the setup will look on the machine. Okay, so here we see how we can make a predefined setup on the machine, or also I can store it in storage and mount it on the start when I want to use it. So this tool table will be used for the part what I'm going to show now. Okay, so I'm going to prepare part. So I did everything. I prepared the holders library. I prepared the assemblies to save the time for definition of tools, and I'm going to make a part. So let's start from simple part on this machine. Okay, I'm going to make this nice screw and a new metal. Okay, I have a classic interface of definition of the part and everything. So people who are familiar with SolidCAM and the SolidCAM mill turn is not new. Okay, we know this interface and nothing changed here too much. Okay, so I define the coordinate system, of course. Okay, nothing to change here. And the stock will be defined automatically. Okay, I'm only just need to edit the target. I also can do it automatically. For this part, I decided to do it manually. Okay, it's take a while. We're parsing the part, making the profile of outside geometry of the part. Okay, the CAM part is ready. So what I want to do now is to make fixtures. So for this part, I'm going to define 3D fixtures. So I'm just make an insert component. Okay, I want assembly. Go to my folder with what I have. I have two different chucks, 8-inch and 6-inch. I will start from, let's take both of them. Okay, so this is a 6-inch chuck, and second is an 8-inch chuck. Okay, I'm using my mounting tool. Okay, to make a mounting of fixture on relative to part. Reverse it. Okay, we'll make a dimension here. Okay, let's say 3 millimeter. Okay, I will make it parallel. So the first chuck is ready. I'm going to make a second. Okay. I will move my jaws to this surface. Let's make it parallel also. And before I want to move my jaws, so I'm going to make this subassembly as flexible. And now I can move chucks, jaws to the part. Okay. Okay. Save this. And now I have an assembly of all components on machine, what I'm going to use for my CAM part. Okay. So in general, this is I don't need to see it anymore. Okay, I will hide it. Okay, and let's define the setup for the machine. I will start from setup. So I'm going to add a new fixture. Okay. It will be 3D fixture. Okay, let's make tolerance of 0.2. We don't need it to be too much. Okay, going to cut selection. I'm just picking on the 3D model. Okay, on the subassembly, making resume. So now all components are automatically imported to SolidCAM assembly. It'll take a while. We need to build an envelope. Okay. Okay. The first chuck is done. We can create a 3D model and see it on the machine setup. Okay. This is my machine. And here I'm going to move my chuck. Okay, I'm just dragging it here. Okay, I know this chuck is 206 millimeter. Okay, distance. My part is already on position. I can continue with the second. Okay, I'm going to add a new fixture. Of course, it's 3D model. Going to the cut selection, and we will repeat the process. Now I am selecting the 6-inch Kitagawa chuck. Okay, and make a fixture from it. And of course, I have to move my fixture to proper position. 30 millimeters is okay. So I have a setup done for part. Now I need to make a setup for the tools. So I'm going to toolkit. Okay, and I see my machine is here. Okay, all what I need to do is to prepare tools for my CAM part. I'm going to my machine library, okay, what I prepared before, has this, okay, double click on it, and here I see the list, and to see the tools I need just open tool picture. I will see all tools what I have predefined in this library, okay, and which tool I'm going to use for the CAM part. So first, I've already remembered the geometry, so I need some rough tool. Okay, so I'm going to search for nice rough tools. Okay, maybe this one. It's good. It's maybe used by two sides. So I will put this tool on the first station, and we see it's immediately mounted there, okay, in proper direction. Okay. A second, I will need some finish tool. So this one is really good for me. Okay, I will put it on third station. Keep some space. I see it's for a back spindle. Okay, I can just copy and paste same tool to the second station, and I can reverse it for the main spindle work. Okay, so what I see here is a tool for main spindle, tool for back spindle. I'll continue. I need to make a thread on this tool, so I need some thread tool. Okay, so maybe this one is good for me. Yeah. Yeah, it's perfect. It's 2 mm step. It's exactly what I need. I'm just dragging this tool to the next station. Okay. And what we see here, it's already done. I will need some kind of milling tool to mill the head. Okay. So let's see what we have here. This tool, this looks not bad. Okay. So I can drag it also to the other station. And in general, my setup done here. Okay. So it's really like a Lego style. I can play with it. If I want to move this tool from the first station, I'm just dragging it here, and of course it will be mounted to the next station. So the changing of setup is really easy, and it can be done anytime. So once I finish it with setup, okay, I can continue to program my part. So how are we going to make it? I'm just adding interning operation. So the interface here is completely same as in previous versions, okay? And I'm selecting the geometry, nothing special here. Okay, let's take a tool for it. And now I want to use my rough tool, okay? And this side of the tool is perfect for this job. So I selected it. And now I can calculate the operation and get a tool pass. Okay, of course, there's a face work. Okay. I will not make finish pass here. And at this stage, I can already see what will happen to the machine. So once I open my machine preview, I will see my tool is near my part, okay, and starting to work on it. I see the spindle direction, it will rotate in this direction, okay. I can run a simulation for it. Of course, I will use a new simulation because I like it. And in this stage, the first time is take a while when you're loading it, but you will see on next operations and going very fast. What you see here is how the machine looks like. See, even your turret. Okay, this functionality to see all turret with all tools you will get in SP1. So don't expect to get in SP0, but I think it will be really nice to get it. Okay, so I'm making simulation. Okay, everything fine. I can go continue to program the part. Let's do it fast because everybody who watching this webinar more or less familiar with SolidCAM, I believe, and know how we making parts and everything. So I selecting the geometry. Let's make this one. Select the same tool. And I will select rough technology. I don't want descent motions. It's done. Go to the next step. We can continue really fast with it. And I'm going to make a thread. In thread turning, we have some kind of improvement last years, and I hope I will show it how it works now. So once I select the tool, okay, let's go to select the thread turning tool, okay. I can go to the levels, and okay, this is M20 with step 2 thread, so I will set here 70.8 millimeter minor diameter. Is the pitch is a 2 millimeter, and what I want to do here is the first step will start with 0.5 millimeter, but the minimum step it will be 0.1 millimeter. So you will see in the toolpath we're starting with big step and descending it till we reach the limit of 0.1 and finish the thread. Okay, so it's allow you to keep the constant force on the tool during the thread cutting. Okay, also of course you can use the patterns, okay, to also cut in some particular direction if you want. I will edit my geometry a little because I wanted to extend it, let's say 3 millimeter to each side. Okay. And the thread is done. I'm going to add additional turning operation to cut this side of the part. And yep. So here I'm using now the 35 millimeter tool, not this one. Okay, I will use the second one for the main spindle. And of course I have to make a rough. Will not make a finish here. Okay. And the last operation on this side is just make a simple turning finish on all geometry of the part. I will start from here and finish here in different direction. Start from here till here. Use the same finish tool. This one, sorry, this is a for back spindle. My mistake. Let's go to the main spindle. This tool is for the main spindle. So I'm going to make a finish only toolpath. I will make a link with arc and some kind of tangent extension of the out. So, okay, I'm going to see the toolpath in simulation now. So let's make a new simulation. Yes, of course. Okay. So what we see here, we see very smooth working. I'm using the mode of playback, like a real machining time. Okay, we can, if you want to move it faster, you can switch to performance mode, and it will be work much faster. It's usable for operations like HSM, HSR, where the toolpath is pretty long, and you don't want to move it by real machining time. But for this particular part, the toolpath is pretty short, so I can really see how it's working in the time machine mode. Okay. Okay. Once we verified is the toolpath is perfect. Okay. I want to go and move the part to the back spindle. So this operation is mainly called transfer. So I will make an MCO operation. Okay. First, I will move my rotary to some safe position. Okay, I don't want it in the position when it's finished. So I go into home reference, also in Z, and also in Y. Okay, in any position, I can see also the position of the turret immediately. Okay, when I finished my definition of MCO. So I finish here. The next step will move me to the safe position. Okay. A second operation will be go to the sub spindle. Okay. I will move it to the setup location, catch the part. I will clamp on the part. So a close and stock operation, and I will, of course, I need to open my main spindle, open it, and go again to the back spindle and move the part together with the back spindle to the home reference. Okay, I finish the process. I can call it transfer. Okay, and of course I can save it as cycle for next use. I will not need to define all this procedure and add additional if you need a kind of stop spindle, start spindle, and everything. Okay, this is a simple definition. Okay, so transfer is done. I continue to work on the back side of the operation of the screw. So let's do it also fast. It's a simple operations. I make a turning here. Okay. I will use a second mark for it, sorry. The tool. I will use the same tool, number 10, but I used for my main spindle, but I will use the right side of the tool. Okay. I have a tool path here, but of course this tool path will be like a backside spindle. Okay, and I will use it for link the left corner. So here's the rough operation. I'm going to add finish operation and see how we can use same geometry. Select the back spindle finish tool. Okay, this one, number 3. Of course, I need to select proper technology, and the link should be from the left side. Okay, we finished the rough operation and finish operation. The part is almost done. Only one thing we need to do here is to add the screw, the head machining. So I'm going to add the milling operation profile. For a milling operation here, I need to add a new coordinate system. So I'm going to add new position for Mach 2. Okay. So it will be somewhere here in the middle, not such care from it. Okay, the default parameters. And select the geometry. So when I select it, on the downside is automatically recognize the dip of the geometry. Okay, we have 16 millimeters. Let's make it minus 0.5. Okay, to ensure we are machine everything. And I'm going to select a tool, and the tool is an end mill, what we predefined in my tool setup. And going to technology, make a graph for it. Let's say 10 millimeter equals step down, 0.5 millimeter graph, and we're using a geometry is not the right direction. So let's do it again. Reverse it, yes. So In general, I finished my setup. Only one thing I want to do here, I will switch to the 4-axis working on a back spindle because I wanted to machine with axis polar state. Okay, so it's what we did. Part is finished. We seen the setup is like a Lego. We can assemble it anytime. It takes few seconds, few minutes, but it's really flexible. I didn't play with holders and I can edit it anytime. Only one thing I want to do now is just to add the operation. So I finished my part. I want to remove it from my sub-spindle. So I'm going to make release stock operation. I will call this operation release stock. And this operation is very important if you want to manage your part in multi-channel. So first, let's simulate the part in the SolidCAM simulator, okay, to see if you don't have any kind of collisions and the tool path is good for us. Okay. So this simulation is working really smooth. Okay. Actually, I didn't see my back spindle. Give me a second. Okay, I think it's my fault. I need to use the Mach 2 here. Okay, so I have to redefine my fixture. It will take a second. I'll go to my fixture, 3D model. Let's take this 6 inch chuck. Cut selection. Let's see if the picture is on the place. Okay, perfect. Okay, starting from main spindle. Okay, so let's simulate it again to see if we don't have any collision in the back spindle. Okay, we're starting from the main spindle. Everything is nice. Still don't see my fixture. Okay, important. What I want to do now, okay, is to machine this part on both spindles and save the tool change times. Okay, on this machine, the tool change time is pretty short, but you still can get a few seconds to find it out. Okay. I think I forget to close it in stock. Now I know why I didn't see my fixtures. Okay, my fault. I'm going to make a channel synchronization here. Okay, so the release stock should be done with the sub spindle. Yes, perfect. Okay. So in this case, okay, the channel synchronization will show me the same process what I see in a country. So it means all operations on main spindle are done, and after it I continue to work on the back spindle. And what I want to do here, okay, first is really important about this this operation. It should be defined at the end of your operation. This operation is shows to SolidCAM. We are releasing this stock at the end. It's not stay in the back spindle. So if it's not released, it means the part transfer cannot be done. Okay. So how I say it, it can be defined really easy by just, I will delete it, okay, and okay, by dragging the sub spindle to the here, and in clamp we have this release stock operation. So it's very important operation in SolidCAM, and it should be defined, okay. So once we define it, we see it appears here, okay, and now I can say my operation is divided by two different workpieces, because till now we see only one workpiece. We start from the main spindle, transfer to the back, and finish work. To split it to two workpieces, I am just add a new workpiece here, okay, and dragging my setup to the start, okay, release stop to the end, okay, setup to the start, and now I can say, okay, I have a one operation with T10 here. So two of these operations can be executed after it. Okay, so I will not change the tool. After it, I have a T3, and maybe if I will move my T3 and T4 operations here, okay, I will save also a little bit time. Okay, we can play with it. It's a closed tools. So I can save here a few seconds, and of course I will see the machine process in machine simulation will done on both tables. So once I start the machine simulation, there's only one way today in SolidCAM how we can verify the channel synchronization is to see it in machine simulation. Okay. So we're loading the machine, have a lot of STL holders and part and everything, and we start with the machine here. So I see the main spindle holds initial stock. I see the back spindle holds half done part. Okay. I'm going to simulate it step by step. The machine starts to work from the back spindle with tool number 10. Okay. When it's finished here, it will move to the back to the main spindle. Still, okay, with same tool holder and machine here. So you can see the machining, and when it will finish here, it will come back, finish work to the back spindle. So this kind of machining, of course, it's much more productive than like regular moving from spindle, making all operation on max spindle and moving to the back. So how we see now in the simulation also, we transferred the ready stock to the back spindle, and here cycle is ended. And of course, next cycle we'll load a new part, and now we can make it in the cycles. Okay. So how we see here the operation, the definition of setup on turrets, it takes minutes, and if you have already predefined holders and predefined 3D models of fixtures, it takes minutes to define it in the CAM part, and even for this simple CAM part, it really can be used, and it's give a lot of flexibility in definition. Once you want to change the station of your tool, you just can go here to the tool table, okay, and just drag your tool to different station. Want to put it in station number 1, you will see the assembly is changed directly on your machine preview, okay. The position of tool will be changed, and of course, if you have kind of collision with material and with opposite tool, you will see it in simulations. Okay, so I change the position, just save the operation, and now I can run my SolidCAM simulator and see where is the tools now. Okay, so you see now the position of tools is changed. Okay, and if we have any kind of collision, we can solve it by this way, because it works fluent and simple. So it was a short demonstration of a new like workflow in Milton. I didn't show here some complex tools with complex parts and 5-axis working or Swiss type. It will be next webinars. I also didn't explain about the features, how to do it, because it's not like a training webinar. But of course, each feature what you see now, we will prepare short videos with clear explanation how it should be done, how we can done, and we did it, and what is a way to make it faster or simplest. Okay, so how you seen, I created the new tool table of few tens of folders in 1 minute. Okay, if you can download hundreds of folders, it will take same minutes. Okay, so it's really fast. You can use if you get your holders or chunks or tools in step format. It's very useful format for machine for tool, but you can download from web. I suggest to you to use SolidCAM, SolidWorks tools. Okay, you can go to the SolidWorks tools and found here a really interesting tool that's called Task Shelter. Okay, so this tool, and you're welcome to play with it, and you have a very good help about it. I am using import and export tasks when you can set wall holder with hundreds of tools converted from step format to SolidWorks format and export to same with SolidWorks format to export to STL. So you can it's run on background. It takes few minutes to do it. You can drink your coffee, and hundreds of tools will be converted to STL format. Really easy. Okay, you can control parameters here. Okay, and do everything what you want. So I really recommend to play with this tool. It can save a lot of time. You just download all your step tools to one folder or a few folder structures and make it by one click. Importing of tools to the SolidCAM tool table, it also takes seconds, and once you save it, you can use it, you can share it with other programmers, you can play with it as you want. So, thank you very much for attending this webinar. Okay, we will continue with other webinars, and yeah, thank you a lot.
Okay, Michal, thank you very much. There are just a few short questions, and I'll go through them as quickly as I can. One was, do you have the possibility to use this setup as a template part to replace components to the machine?
Of course. Okay, I will show it. It's a good question. So in machine, of course, you remember, so we have like a machine tool table. Okay, give me to find it. Tool setup library. Okay, so you can go here, okay, and say which library you want to use. So in this case, I will select the DC DS30. Okay. So once I save it, I will go to make a new part just to show how it works. Okay, so I just let's make same screw again. Okay, I will not pass all the process. Don't worry. Okay, again. So I will open this part and let's make a new CAM part. Okay, I have to pass this process with coordinate system. Okay. So once you go to the tool library here, okay, you will see all your setup is already here. So I show it the long way to it. The proper way is, of course, if you have kind of table what you want to use for any setup what you're going to do, it's like a predefined. I know from my experience, 80% of tools what you hold on your rotary turret never move from it. Okay, so it's general groove tool, cutoff tool, normal generic rough or finished tools. They stay on the stations always. And yeah, of course, how you see here, I have already predefined setup here, and I can of course use it for this part. Okay. So thank you for the question. I hope I answered you.
Okay, and okay, I believe you can answer this also very quickly. Is it possible to use STL files also for the inserts of turning tools, not only for shanks and arbors?
Of course, you can use it for both turning tools, cutters, milling, and turning. Of course, it's the subject of next webinars when we will show how to use it. I can just show a short demo. Okay, I just don't want to take too much time from you. Okay, but I will show you the short demo of how we use 3D tools. Okay, and I hope it will answer your questions. So this one I go to close. Okay, and I will open other part. And this part, if we go into the tool table, you will find a few tools, and all the tools are 3D, so you can really see the insert. Okay. Also the cutters are 3D. Okay. We can use special turning tools. You can use special shape tools as 3D, and of course special internal tools. Okay, and in this case we are using even shape tool to cut special geometry on the part. So I will show you how it works, and it looks really amazing. Okay, so we go to this shape tool, and you really see here how we making the geometry. Okay, and I really like it. Okay, I know a lot of factories are using this kind of tool, is provide incredible productivity, and today we do support it. So you can draw the tool, make a STL model, and we will make videos with clear instructions and explanations how to do it properly. Okay, and of course it's done. So thank you for the question.
Okay, one last question, and the rest. Okay, yes. Okay, it's a simple question. Adding a lot of tools into library, will this slow down its loading when you load the library?
Of course, I can answer this question. So this, I just can open simple library and I'm doing it at real time. Okay, and I think I showed it in a previous webinar, but I really like to show it. So I have this with library. This library contains 387 tools here, 100 chunks, and almost 200 holders, and all chunks here is a 3D model. Okay, so you don't say it works slow. Of course, if you are using it's in high definition, you mean you are making STL models in really high definition. Okay, we have limits. Okay, it will slow down the process and simulation, for example, but not the tool table. For tool table, we are not care about the size of the tools, number of tools, and the size of the 3D file. Everything is working really, really fast. And but if you want your simulation working fast, so don't use tools where you don't need it. Okay, 3D tools. It's something what you know. It's done for special tools. If you're using end mill 10 millimeter, really no sense. There's no sense to put it in high resolution 3D model. But if you have special shape tool, okay. So for this particular tool, it will a little slow down the process. You've seen it now in my demo. I will show you, for example, this simulation of this 3D tool. Okay. So once we go into simulation, you don't see it's like with all fluids, okay? You see it's working very fast and it's not slow down the process. So on this kind of short operations, you will not feel it. On big operation, but again, it's something what we can live with it, and it's much faster than previously. And for special tool, of course, is a proper solution. Yeah, thank you.
Okay, Michael, again, thank you very much for the webinar, and we hope everyone enjoyed it and got a lot out of it. And we will hopefully see you again next webinar. Take care, everyone, and have a great weekend. This has been recorded, yes, it has been recorded, and will be available to everyone on our website. Take care and have a great weekend.
Okay, thank you very much. Thank you for everybody. Okay, see you. Bye-bye.
Bye-bye.